Good morning. It's Wednesday. I think it's April 8th. It's still morning here. I'm not sure if you see the AM, but this is number 8. This is sign test video number 2. I said on Monday, I think, when I posted the first one, that I would try to post a one-tailed one. And this is my one-tailed test. You have this page I sent you, and this is number 8. It talks about the weekly earnings of women. And according to the Bureau of U.S. Department of Labor, the occupation with the highest median weekly earnings for women is a pharmacist, and the median is $16.03 per week. Based on this data, listed from a sample of female pharmacists, can it be concluded that the median is less than $16.03? So the less told me it was one-tailed. So I have equal $16.03, less than $16.03. And this time I didn't write the data down, but I looked at each data value. And if it was below 1603, I put a minus. If it was above 1603, I put a plus. And instead of just putting the 15 numbers and a plus next to them, I just replaced each number with either a minus if it was below 1603 or a plus if it was above. And there's my 3 columns of 5 numbers. And then when I was done, I counted up, let me straighten my papers, I counted up and I had 6 plus signs and 9 negative signs. You always take the smaller. The test statistic is always the smaller of the two. And that's a pretty big statistic. That's a pretty strong evidence that you are not going to reject. Because if it is the median, these numbers are supposed to be equal. And there are 15 numbers, so they should be 7.5, 7.5. And that's darn close to 7.5. So the bigger your test statistic is, the less likely you are to reject. And then you go to Table J. I shared with you the copy of Table J. I'm finding it here. And this is, we have, if I can get it over far enough, there it is. It's my bookmark. N is 15. It is one-tailed. It was 0.05, so that gives me a test statistic of 3. Or a critical value, I'm sorry, a critical value of 3. So that's where that came from. And those are the 3 pieces of information you need for critical value. Your alpha, the number of plus and minuses, remember, because I didn't have any data values that were equal, that were exactly 16.03, I had the 2 plus and minuses added up to the exact sample size. But remember, if you subtract, or if the data value you get is exactly 1603, you would put a 0 there. And zeros do not count in your N. And it's written on the table at the bottom. It says, remember that N is the total of plus and minus signs only. And there's my do not reject and my conclusion. You'll notice there's no diagram here. We are going to, over the course of the next month, we will see very few diagrams. Here on the table, it tells you, at the top of Table J, where you got your critical value, it says reject the null hypothesis if the smaller number of plus or minus signs, the test statistic, is less than or equal to the critical value. And you will not have a whole lot of rejects. And you'll also notice on a sign test that these plus and minuses don't have anything to do with how far the number is from 1603. Your weekly earnings could be 602, or they could 1602, or they could be 602. The distance from the median doesn't matter, and that's a problem. That's why the sign test is not really overly accurate, because it isn't based on a whole lot of information, and that's why you need such a big difference between the test statistic and the critical value to reject. You are not going to see very many rejects here at all. Now there is one other piece of the sign test that we're going to do. There's actually 2, but we're not going to do the sign test. You can do it with larger pieces of data. that are above 25 that you can't use table J with. But if we get a chance and we get back to school, I might throw it in then. But for now, we are just doing small sample sizes, 25 or less. Now, when we did the t-test, which is what this is a partner to, because t is small sample, we did it with independent data, which is what this was. You had 15 independent people. These were all 15 female pharmacists and their salaries. Then we had the dependent test, which used dependent data. And we put them in L1 and L2, and we subtracted them, and we did a t-test. This partner, because we can't do a t-test here because we are now in non-parametric statistics. This data is not normally distributed, and that's why we have to use a different test. And this is just the paired sign test. It's easier than the t-test. These non-parametric tests do not use standard deviations and means, therefore they're not quite as accurate. But we can use a paired sign test with dependent data. Dependent meaning you're using the same set of data and you just take like a before and an after, or a pre-test and a post-test. And in this case, for example, let me show you the one that I did. I think I did, let me find my other page here. I did where'd I go? Here I am. I think I did for you number 15 here. This is a paired sign test. Here are your subjects. There's 8 women or 8 people here. Person A, this is their weight before and their weight after. You have to make sure that these stay paired up, that this is person A, their weight before and their weight after. You can't sort these or put these in any kind of an order. So this is dependent data because each set of data, these 2 numbers belong to a person. And this one says that there is a study to see whether a certain medication had an effect on weight. These are women. So here's your 8 women. Here's their weights before and their weights after. And you just take a look and see what the difference is. And N becomes, you take a look at each pair of numbers, subtract them. If the difference is positive, you put a plus. If the difference is negative, you put a minus. If they don't change, if they have the same weight before and after, you assign it a 0. N is the number of, usually the pairs of people. It's not, we had 8 women, but we had 16 numbers. But it's N is the number of data pairs. And in this case, it's going to be the number of plus and minuses you see them when you subtract each pair of numbers. Again, zeros don't count. And I did that number 8, I'm finding, or that number, I think it was 15. Here we go. So here was, this is number 15, diet medication had no effect. Remember always, NHO is always going to be that that something is equal. It's either equal to the median, or in this case, the diet medication had no effect because the before equals the after. The symbol equal must always go in HO. And here the diet medication had an effect. Maybe it went up, maybe it went down, we don't care. We don't care if they gained weight, we don't care if they lost weight, we just want to know if the weight changed. I didn't put the A, B, C, D all the way up to H, but these are your 8 women, right? 2, 4, 6, 8. Subtract the numbers, and you just put a plus. Now a plus would be good, because a plus meant they weighed more, and then afterwards they weighed less. So a plus indicates that they did lose weight. Here, someone gained weight, plus, plus. So as you look at your 8 people, 7 lost weight, 1 gained weight, your test statistic is 1. If you go to the table J, the table I just went to, alpha is 0.05. There are 8 plus and minuses, and it's 2-tailed. And that gives you a critical value of 0. So even though it looks like this medication's working, just about everybody, with the exception of one person, lost weight. But because the sample size is so small, there's only 8 of them, you would have had to have all of them lose weight in order to get a critical value big enough, or you may need a different alpha to get a critical value that's 1 where we could actually reject. It is very rare when you reject in the sign test. And then there's my conclusion. Because we did not reject this, it appears as though we can't support the claim that the diet medication had an effect on, I wrote weight twice. I was going to put weight loss, and then I said, well, we don't want just loss. We just want to know if there's a difference in weight, because this was 2 tails. I meant to just stop there. Okay, so there's your paired sign test, your sign test. They're both basically the same. You have numbers. You give them pluses or minuses. You compare them to the median, not the mean. If it's a regular sign test, like number 8 was, you put your median that they give you up here, and then you just put pluses and minuses. Count them up. The smallest number is your test statistic. If it's a paired sign test, you just compare your numbers. If you subtract them, put a plus. If it's positive, subtract them, and you get a negative, you put a minus. Very easy test. I tried this week right before Easter. Nice, easy week for you. Now, what I would like you to do, I am going to post. You have this page in the book that had number 5 that I did. You are going to try to do number 6. And you can do it just like I did on line sheet of paper. You don't really need a form. It's not, all that difficult. And I am going to post this page, which is the next page, and you're going to try, I did 15, you're going to try 16. And I have it right here. And I would like, if you could, just take a picture of that and send that to me by Friday. Today's Wednesday, by Friday at 5 o'clock. If you have any questions, if you think you want to Google Meet to ask some questions, just send me an email, let me know. Email me any questions, and enjoy. Hope everything's going well and everybody's healthy, and I will talk to you soon.